My name's Patrick Leyshock. I'm here from Portland State University, and thanks for the opportunity to speak with everybody. If you're like me, you're dealing with the same problem. There are a lot of engineers and scientists that want to analyze large collections of data that are typically modeled as multi-dimensional arrays. And traditional tools are letting these folks down. Analytic systems aren't working well, and database systems are not working well. There's a few different approaches to get around this problem. There are three I want to talk about. We can make analytic systems work better with large collections of data. We can create databases that are capable of more sophisticated analytics. The third approach, which is the approach I favor, is called the hybrid approach. And that's when we combine an analytic system with a database. So we let each do what it does best. A particular example of such a hybrid solution is one that I'm working on. I call it Agrios. It is the integration of R and SciDB. R is the analytic system. SciDB is an array-based database system. It's the database component. And in a pure hybrid approach, as Agrios is, we're going to be doing work at both locations. So we're going to be doing part of the analysis at R, the analytic engine, and part of it at SciDB, the database side. What this means, if we're doing work at both places and we're storing data at both places, is we need to move data back and forth between the two systems. Made a few contributions. The one I want to talk about today is the strategy for moving data back and forth between the two systems. There's two things I want you to leave here today with. One is that we should attempt to minimize the amount of data moved between two systems, and the second is that we should automate this minimization process. Now, decisions about data movement matter. It comes as no surprise that if vectors R and C are stored at B, we want their product at A. There's a big difference between shipping the vectors from B to A and doing the computation there versus performing the computation at B and shipping the results. There's a big difference there. And we want to, again, minimize the movement of data because it's expensive. What this also shows us is that reducing the amount of data moved amounts to making good decisions about where we perform operations. So hopefully I made the case that we want to minimize the amount of data. Why do we want to automate this process? Well, what's the alternative? The alternative is to perform it by hand. So I've got a script, analytics script. I can sit down with it and say I want this operation to be performed here, that operation to be performed there. That's all fine and dandy. However, our tests show that if we vary the shape, location, size, compression, and so on and so forth of the inputs, then we may have a different way to annotate the script. So the script I just hand annotated that moved the minimal amount of data. If we switch the inputs, all of a sudden it's moving far more data than we expected. So there are three strategies for automating this process: staging, rewriting, and consolidating. A staging is an answer to the question, where do we perform operations in a script? So you can see the colors up there. Different colors mean the inputs are located at different locations. A staging is basically a statement that we're going to perform this operation here, that operation there. How do we stage? Well, there are some stagings. We want to pick the best one. How do we do it? We have retooled a optimizer from a relational database system to work with this system. And we use a cost model. It takes into account various properties of the inputs. We use a top-down memoization approach to explore the search space and pick the best staging. That's fine. However, we find the optimal staging. However, that only gives us the optimal staging as far as the query or script was originally written. This leads us to our second strategy, which is expression rewriting. Again, leveraging lessons from database technology, we can take a plan with a certain staging, rewrite it, for example, using association. And in this particular example, we've cut the amount of data moved in half. Thanks for your time. I'll be at the poster session.